Hello everyone, today I have a very special interview. I'm on my way to see Professor Anthony and we're going to be discussing everything about bioprinting and biotechnology. Hello, come in. So, you want to know more about bioprinting? Well, let me show you. Bioprinting is a subcategory of 3D printing. Using special materials that are biocompatible with certain cells, scientists are able to artificially create biological structures such as tissue. Currently, researchers have been able to work with cells such as stem cells, bone cells, and cancer cells, which have been used to test for potential treatments. For a material to be biocompatible, a medical team needs to collect data about the tissue or organ in question, such as its shape and size. Then, with the data collected from the patient, the team members can concoct a Bioink. Think of Bioink as a habitat for living cells. They are a material used in bioprinting that supports the growth of living cells by giving them important chemicals they need to live and create functional 3D tissue. There are two types of Bioink: scaffold-based Bioink, a Bioink filled with hydrogels, and scaffold-free Bioink, which does not require hydrogels. However, they serve the same purpose. I use the word hydrogel a lot, but what does that mean? Hydrogel is a bacteria that supports the cell growth of Bioink. According to Professor Molly Chouchet at the University of Toronto, hydrogels immobilize multiple proteins in order to maintain a cell's protein bioactivity. There are multiple types, but the one that is the most commonly used are the water-based gels. What makes water-based gels so special are the polymers inside of it. Polymers are large molecules bonded together through chemical processes. They join together in hydrogels to make the printed gels stronger. Now you know all the materials involved, here are the 3 steps of bioprinting, which takes about 8 weeks to complete. The first step is the pre-processing stage, where scientists create a 3D model based on the data of the patient. The next step is the processing stage, where the tissue or organ is printed. Layers of Bioink are added together to print out the material using a bioprinter. And finally, the post-processing stage, where the transformed print becomes functional organ or tissue. They place the print in a special chamber which helps cells mature properly. But with all this said, what are the applications of bioprinting? Bioprinting has created tissues that otherwise are unable to regenerate, such as heart tissue. In the past, we have bioprinted tissues, bladders, lung tissue, bone cartilage, skin, and semi-functional kidneys and livers already. However, there is still room to grow. We are still unable to print entire functional organs yet. And there is still 4D bioprinting, where printed tissue and organs can evolve over time even after they are printed. Like this Eiffel Tower, 4D printing allows the organ to be able to change shape or function when exposed to a stimulus, such as heat or pain.